uh, let's come back to recall what we have learned about supervised learning and unsupervised learning and how that they can be combined together in deep learning. So when we have supervised learning, so we talk about we have a bunch of training data that would be the feature X and also the label information. So given a lot of data like this, right? So we want to link between the relationship between X and Y together so that later we can have some label prediction given whatever the new X prime, then we can predict what kind of function Y prime that we may have, right? Even let's say X prime and Y prime are not, is not in the training set, okay? So the source learning is relatively precise, so therefore that we have been uh, studying this topic for quite a while, for decades. Okay, yes, and on the other hand, the unsupervised learning, we just focus on finding the relation between different acts, or such as finding their similarity or distance, or how to cluster several data sets together in one group. Okay, so that's unsupervised learning. And remember that we mentioned Jan LeCun's comments on learning algorithms. So between reinforcement learning, supervised learning, and unsupervised learning, so he mentioned that we use a cake to illustrate the difference between different algorithms or different problems. So the supervised learning is like icing on the cake, okay, icing on the cake. And we know that when we eat cake, right, so we better to have some icing on the cake, right? But it's nothing uh, that important if compared to the cake itself, right? So what is the cake itself? That's unsupervised learning. So Yang LeCun say that between supervised learning and unsupervised learning, and if we are given one sample, so one sample, the supervised learning gives us the information like the label, what kind of label that we have for this sample, right? So unsupervised learning, in fact, we have to, we can pay attention to all the different attributes, okay? All the different attributes. So that will be something that we need to think about. Yeah, and I mean something that usually we focus more on the supervised learning. In fact, according to Jan LeCun's comments, right, it will be just what? It will just be like a few bits per sample, right? The unsupervised learning, instead of that, will have millions of hundreds of bits per sample because all the feature information will be the thing that we can pay attention to. Compared to supervised learning and unsupervised learning, the reinforcement learning, we don't have much information per sample just because, just like playing chess, right? So each move, right? So after we finish again, we know someone's win, someone lose, right? Uh, so after that, we know for each of the moves in a game could be good moves or bad moves, right? So per sample or per move, we don't see a lot of information because after all, we just know a single answer like this game. Someone wins or someone loses, right? So not much information, okay? So overall, he Jan LeCun said that reinforcement learning is just a cherry on the cake, right? So I mean, it's important, but it's not as important as the cake itself to make us full, right? Okay. So given the Jan LeCun's comments, right? So in fact, that if we talk about deep learning, why we have the successful story from deep learning is one reason is that the deep learning can deal with label data and unlabeled data at the same time, right? So which means that for the label data, of course, we try supervised learning, right? For the unlabeled data, maybe we can try some kind of unsupervised learning or maybe autoencoder to be more specific, right? so that using the information on supervised learning or using the information on labeled data, we can also have less gradient vanish problem. Okay, so that's how that we can use deep learning to dig more information from the data. So in fact, that in deep learning, we can work with the supervised learning in the sense that we link between the input X and label Y, right? For the unsupervised learning, we want to find the hidden structure in X, okay, such as autoencoder, right? So when we try for the supervised learning, we try backpropagation, just like we say. Sometimes we will run into the vanish gradient problem, and for the autoencoder, we probably don't worry too much about this vanish gradient problem. So that when we have a when we have a deep structure, uh, some people actually say the following, right? So maybe I can have to draw things like this. So some people say that when we have a deep network, right? Maybe I draw the deep network is like this, right? I draw the deep network is like this. Okay, so maybe a lot of things, right, in the middle that we say the deep network because a lot of layers, right? A lot of layers actually is devoted to find out the hidden structure on X, hidden structure on X, which means that maybe this belongs to, I mean, suppose that we should pay attention to unsupervised learning, meaning that we want to find nonlinear structure, okay, maybe highly nonlinear structure on X on the in an unsupervised manner, right? So maybe some part that belongs to supervised learning, right? Supervised learning, okay? Don't be just not so, doesn't need to be a lot of layers, right? Maybe near the end of near the output layer, then we just need to have a few layers to talk about supervised learning, and still that the main part to make the uh, model to be successful is rely on supervised learning. So therefore, even that we have a very like a highly nonlinear model, like a very like a model with a lot of depths, right? So a lot of depth actually spend more on the supervised learning part. So that's something that we can think of, right? So usually people believe in this way. Okay, so yeah, so just like I say, right? So in deep learning, it's common to have both supervised learning and unsupervised learning structure combined together, and we can take advantage of using two to get a better performance. In fact, that the way to combine supervised learning and unsupervised learning doesn't need to be just one way. Okay, doesn't need to be just one way. Okay, yeah. So we talk about this part, and then next is we move on to talk about autoencoder.